Okay, welcome. This is an explanation of the calculation summaries for the final lab project, as well as the proposed lab setup. There's a couple of different components to this proposed setup. The first being the hollow plastic tubing for the vein. Inside would be a mixture that would very closely resemble blood to get the pressures right. There are a number of different substances that can suffice. This drawing says oil or water. It would probably be more along the lines of corn syrup or something similar. Also, there would need to be a voltmeter, ammeter, multimeter, or some other tool to measure the magnetic field, which the magnet itself is labeled here arc reactor since that's what we're studying, but it would actually be some sort of a magnet that could generate a current and a magnetic field. This is the more general just piece of tubing. It wouldn't necessarily be in this configuration, but it would be of a certain length, it would be of a certain diameter, and it would be of a certain pressure with the viscous fluid that resembles blood. So in order to determine whether or not the magnet would be able to actually counteract the forces that the blood is pushing onto the piece of shrapnel, we need equilibrium conditions. And in order to find a summation of all of our forces, we need to first consider the different forces that are actually acting on our metal shroud, because we want that piece of shrapnel to be in equilibrium. So the first force that is acting on it is the force of blood, which is P times pi r squared times L, where P is the average pressure of blood in the body, R is the radius of the vein, and L is the length of the vein. The P value has been found already in a medical journal or two. I don't have it listed here, but it is a known value. The R and L would be used for the radius of the vein. It would be depending on what type of vein you actually want. We would probably be taking one of the arteries near the heart. And the L is whatever we determine it to be for the experiment. Our second force is the force of the magnet, which is Q times V times B, where Q is the charge on the magnet, V is the velocity, and B is the magnetic shield. Equilibrium conditions would be 0 equals P pi r squared L minus Q V B, solving for the controlled variables Q and B. So the conclusion of this is that in order to draw any kind of reasonable deduction from this experiment, Q and B would need to be evaluated to determine if the practical value for both would yield positive results. As practical is subjective, this would require further parameters or discussion with contributing authors, since anybody's definition of what practical is obviously would differ between person to person. Alright, that just about does it.